Welcome back, friends. All right, so far in substitution, we have looked at a couple of different options. The first option was both equations were in y equals mx plus b. We said, okay, we'll just set you equal to each other and solve. Next up, only one equation was solved. Remember, it could be solved for y equals mx plus b, or it could have said x equals. So somebody had already been found. We knew something about y, or we knew something about x. Well, today, it's changed again. Take a look at these equations. Yeah, 5x plus 2y equals 7, 4x plus y equals 8. If you remember back, these are both in standard form. Oh, what to do? Well, why don't we just solve? Why don't we find something that we can work with? So I'm going to look here, and I'm like 5x, 2, 5, 2. I'd have to divide, if you were solving. I was like, that's going to be messy. I've got a 4 and a 1. Bingo. When we are trying to solve or isolate a variable, unless we're told specifically to find one or the other, we're going to use the one that has a coefficient of 1. I'm going to say that again. I want to use the variable that has a coefficient of 1. And here's why. So if I was to take 4x plus y equals 8 and solve for y, I'm just going to do so over here. I have 4x plus y equals 8. I'm solving for y, so remember I'm going to subtract 4x from both sides. Rewrite this. Y equals negative 4x plus 8. Now, if I had a coefficient in front of the y, now I'd have to divide again. That's why we want this to have a coefficient of 1. If we just move away the 4x, then we're pretty much already in y equals mx plus b. Now here's the best part. I know what y is. Y is negative 4x plus 8, which means I can take the information from here. Now I use this one. I have to plug it into the second one. I can't plug it back into this one. That's not going to work. It has to go into the second equation. So I'm going to rewrite this. 5x plus 2. Open parentheses, remember, that's multiplication. This is where we distribute. Equals 7. So 5x minus 8x plus, still distributing, 2 times 8, that's 16, equals 7. Simplify, 5x minus 8x, that would be 3x. Still have that constant there. Ooh, yay, made it to a two-step. Now we can just think about how do we move a two-step around. So negative 3x, we're the mathematicians that removed that 16. 7 minus 16, well, that is negative 9. But this is working out pretty nice because when I divide both sides by negative 3, x is going to equal positive 3. That makes sense. Okay, I think that'll work. Well, I only know part of it. Remember, we need a solution. We need an x and a y. And I only know x, so that means I've got to go find y. At this point, it doesn't matter which equation you use. You can use either one. Sometimes, like I said, I like to use one and then check it in the other one. So let's try that. I'm going to start with the easy one. I've got 4x plus y equals 8. And I'm going to plug the 3 in exactly where x is. So 4 times 3 plus y equals 8. That would be 12 plus y equals 8. Let's go ahead and subtract that 12 from both sides. And there we go, y equals negative 4. Well, I just want to make sure I'm right. Like, okay, there's a lot of things happening here, right? There's so much going on. I could easily make a mistake. I'm going to plug that x and y into the other equation to make sure I'm correct. So if I have 5 times 3, right, that's the x value, plus 2 times negative 4, well, that equals 7. Does 15, 2 times negative 4, so that'd be subtract 8, does that equal 7? Yeah, 7 does equal 7. Whew, I didn't make a mistake. There's my solution, 3, negative 4. Again, math is so awesome. In algebra, we get to check our answers before we turn them in. How cool is that? All right, next one. 2x minus 3y equals negative 24. Yep, still in standard form, and I need a variable all by itself. Remember, coefficient of 1, if possible, and I have that right here. So I'm going to solve not for y this time, because the x has a coefficient of 1. So I'm going to subtract the 6y to the other side. And x is going to equal, now it doesn't matter which order you write these in. This isn't y equals mx plus b. So 18 minus 6y, or you could have wrote negative 6y plus 18. Completely up to you. X equals. Don't use the equation you started with. You have to use the other one when you plug it in. So 2, now I have the x value, not the y. Be careful. I know x, so I have to plug it into x. So 2 times 18 minus 6y minus 3y equals negative 24. Okay, so distribute, right? So 36, 2 times 18, 36, minus 2 times negative 6y, so negative 12y, minus 3y equals negative 24. We're going to combine those like terms. So 36 minus 15y equals negative 24, because 12 and 3 will make that negative 15. Subtract 36 from both sides. Ooh, I'm glad we made it back to that two-step equation. 36, well, that's going to disappear. We ask it to. So negative 15y equals negative 24 and negative 36. That'd be negative 60. We're going to divide both sides by negative 15. And y is going to equal, well, how many times will 15 go into 60? Yeah, 4. And a negative make a positive. Well, look, I've got that y value. Now I need to go find my x. Does it matter which equation I use? Absolutely not. Do you think I'm going to use the easy one? Yeah, most definitely. I think x plus 6y equals 18 looks a little bit easier than using the top equation. I know y, so I plug it in exactly where y is. So x plus 6 times 4 equals 18. So that'd be x plus 24 equals 18. Subtract 24 from both sides. We're solving for x. And it looks like x cancels equals negative 6. Now, remember we talked, we can double check our work here. So go back and double check your work. Make sure if I plug this x and y value into the other equation, is it still true? And if it's not, then we got to go back and look again.